Hallo en welkom weer by Farmspace. Hoe kies ek my nozzles op my spuit? Wat jy verskillende nozzles van induction, jou gewone, hele lot reg deur. Jack Pickering van Syngenta gaan ons meer vertel oor hoe lyk die goeders. Kyk hierdie cool demonstrasie is awesome.
Okay, we're going to go now. So we've gone over this. So I'm going to go over this quickly. This is I got this off Sprayers 101, but basically this is the inverse of like what you get from T-Jet. So instead of saying finding your kilometers and then trying to find what water volume you're spraying at, this is the other way around. So that's water volume at the top and then your speed. So with the different size nozzles, so to help you select the nozzle, and then according to the pressure, there's your pressure, there's the flow rate, and these are the different kilometers per hour. So in my example here, I want to spray 200 liters a hectare and I want to spray at 12 k's an hour. What does that mean? That means that from the nozzles in picture here, I could choose any 4 of these nozzles. The only difference is if I choose a blue nozzle, I'm going to be basically sitting at 8 bar to get close. I'm not going to be at 12 k's an hour, but close enough. If I choose an 035, which is like a brown red, I'm going to be sitting at 6 bar to get to 12. If I choose a red nozzle, I'll be sitting at 5 bar to be just over 12.4. And if I choose a 05 nozzle, I'm going to be sitting at 3 bar for the same 200 liter application. Why is that important? It's important because obviously, depending on what nozzle I want to select, these two, those pressures are way too high. I'm not going to operate at that. So I'm left with these two. If I wanted to choose an air induction nozzle, I know that they work better at slightly higher, and they also don't work so like anything lower than 2, generally speaking. So these are I've chosen red because I want an air induction nozzle. These are my 2 choices now. There's a knife on the line here. Can anyone tell me which nozzle and why? Which out of those 2 nozzles, which one would suit best if I wanted a nice big variable speed rate? I want to go slow.
Because it's overlapping is better.
Okay, so this is sizing. So this is purely how much water is going through. So they're the same size. They're producing a very similar size droplet, but there's one big difference between the 2 of these.
Ultra coarse, bigger droplets.
That's got a bigger droplet, yes. So that's could be one of your reasons, but there's another one. What happens if I want to go 5 k's an hour? That's not going to work. That one will. So they're both air inductions. So as I said just now, not all air inductions are made. Condolence prize. We're trying. Yeah. Any more questions, guys? I'm going to do some practical examples. So, yeah, so remember we spoke about pressure. So this is a standard flat fan. Let's make sure it is a standard flat fan before I do something stupid. But anyway, that's a standard flat fan. So if I operate this, at a low pressure, you'll see there's not that much drift. If I increase this, so that was 1 bar. This is now sitting at 2.5 bar. That's 3 bar. You can see straight away the amount of those that we very often misidentify as good application. That's bad application. That's all stuff that's disappearing. So you can see that's at 3 bar, and you can see all of the drift coming off here. If I take the same blue nozzle, so it's the exact same size, and I swap over to an air induction, I can go right up to 3 bar. That's at 3 bar, and you'll see where's the right nozzle. Let's make sure that that's the right nozzle. That explains it. There we go, that's an air induction. That's now operating at over 4 bar. Let's make nice round numbers. That's 5 bar. And there's no drift, no mist. So that's all product hitting target. And that's basically the long and the short of it, is that That's the exact same size nozzle, so if I was traveling the same speed, it's the same. I can go from that to that, no problem. But that one, obviously, as soon as I get over 2 bar, there's trouble. The other thing to always remember with nozzles is you have lots of choices even within the air induction. So like something like this, okay.
What happens if you go to a exact apply on the air induction?
Okay, so don't have a good example of it, but basically, sorry. Yeah, man. What happens with air inductions, especially the old air inductions? So remember my example there were 2 air inductions, and the bottom one, the one that was sitting that had needed 2 bar. If you look carefully, there's a little hole. And basically how an air induction works is, air inductions, the reason you don't really want to use an air induction on a PWM, which is exact apply, the reason for it is that air inductions work on a venturi system. So basically they need pressure to go through, and what's happening is you're sucking air into the nozzle housing, and it's actually making, if you look at those droplets under a microscope, there's actually little air bubbles inside the droplets. So that's why they're increasing their mass. With exact apply and any other PWM, so it will be the same for that case, any pulsing machine, what basically happens is instead of the liquid coming out, you'll end up reversing that venturi, and before the nozzle actually opens, it shoots out chemical out the side. With ones that are sort of like this, again, the issue is that you're not really getting the advantage of the air induction because it's not constantly flowing, that venturi is not working lacquer. You're better off going with a pre-orifice nozzle, so basically, so any one of these, the advantage of, so let me just explain PWM. So we all know what rate control is, and as I've explained in my presentation, as you increase speed, you increase pressure. Where PWM comes to its own is because at each nozzle, you've got a solenoid, basically that's pulsing. So a 10 hertz system means that at every single nozzle housing, that thing is opening and closing 10 times every second. Okay. Why is that important? You can set that machine at a specific bar pressure, so you can go into your catalog, find the exact droplet size you want, set the machine at that bar. So as a silly example, let's say 2 bar. I want to operate my nozzle at 2 bar. You select that 2 bar. How the flow rate is then calculated or worked out, how it's controlled, is from that nozzle housing opening and closing. So, what does that mean for us practically? It means that you can basically 4 times your speed without affecting your pressure whatsoever. It'll stay at 2 bar, whether you go at 4 k's an hour or whether you go 16 k's an hour. If you had to do that with a normal rate control system, first of all, your speed variation is much narrower. You can't vary your speed. You can only vary your speed 1.75 times from original speed. So that's basically, as an example, if you started out at 5 k's an hour, you'll only really be able to get to just before 10 k's an hour before you're going to be sort of sitting at like 8 bar. See what I'm saying? So whereas that, this constant. So what does that mean? That means I can take a normal standard flat fan and I can say I'm going to operate that at
2 bar.
At 1 bar. Okay, so not exactly 1 bar, but you get the point. The point is I've limited the amount of drift because I'm operating that nozzle at a low pressure. I can also change out the nozzle. I can go to a red or whatever to just change. There are air inductions that work, but generally you're better off with a pre-orifice nozzle and just choosing sort of the correct operating pressure that you want to achieve. So generally PWMs, most of them size 1 up. So if you had a red nozzle on at your same speed and water volume, whatever that is, if you moved over to PWM, you'd go to an 05, you'd go to a brown nozzle.
What does PWM mean?
It means pulse width modulation. Not width, yeah.
Exact apply.
Afrikaans.
Yeah, that one I can't help you out. I don't know the Afrikaans version of that, but the long and the short of it is that pulsing basically lands, you move away from that pressure problem that rate controllers generally have without losing that variation in speed.
Okay.
Means that you can operate also like nozzles, like if you wanted to, there's like a 3D. So just a bit of interesting facts. This is a 3D nozzle. You can get them from John Deere in their parts department. But this is a Syngenta design nozzle. So Syngenta doesn't make nozzles. So how that works, we design the nozzles, we test the nozzles, we then hand it over to Hypro. All of the nozzles on this are from Hypro, but basically they produce it. And then in the South African stance, we put a John Deere sticker on it and we sell it as a John Deere part, but it's actually made by Hypro. So that nozzle, this nozzle are both our designs. Syngenta over the years has designed 5 nozzles, so through the design process. And then we've also made a couple of specialty nozzles in the vegetable market as well. What's nice to know about this is Hypro and us, and by default, this is one of the few nozzles that basically not only gets tested in the factory and like if you look at T-Jet as an example, great company, but what they do is they basically say theoretical farm application. This would be better for a fungicide. This would be from what we see on our machine telling us. Whereas that got tested in the field. So that was put on a sprayer and tested and said, yes, we can, this is better for this application, that's better for this application.
Which one can you put on a PMS for a broad application?
Yes.
Fungicide,
So what I would do is I would still, everyone hates me for saying this, I would still put 2 nozzles. I'd put, in your case, Exactaply, I would put 2 of these and then I'd go one size smaller, one size bigger. And why I would do that is for my pre-emergence, I would go the size up because I want to operate at very low pressures like this. Because I want a very coarse droplet for pre-emergence. Why do you want a big droplet for pre-emergence? You're hitting a flat target. There's nothing in the way, so as long as that droplet hits the ground, it'll work. So, generally speaking, from our trials, we've seen the best results from either the TTI from T-Jet for pre-emergence. You can operate these at like your 05s and 06s at 200 liters at 12 k's an hour. So you're not going very fast, but you're operating at very low 1 bar, less than 2 bar pressure basically. This nozzle can operate up to 0.7 of a bar. So it's got quite a nice, so you can operate it quite low. But so for a pre-emergent, I want a big droplet because I'm hitting a flat target. For a post-M, I want to be in that medium to coarse because I don't want a too big a droplet because then it's not going to stick. You know, if you have to spray here with lots of water, most of it's going to run off. It's the same concept. You want finer droplets to stick, but you obviously don't want too fine. So that's where you want to go medium to coarse, and then you can drop your water volume down to those 100 liters. Don't go 20 k's an hour, ideally. Stick to lower than 12, but then you'll get better retention on the crop. If you have windy conditions, ideally please don't be spraying in this much wind, but if you have windy conditions, then you basically want something that's between like a extra coarse to extra coarse, like somewhere around there is basically like that extra coarse. Don't go too coarse with your post-emergence. Depends on the nozzle. So again, if you're operating these that are not air induction, you'll just have to check the booklet before, obviously, when you put your machine on where your nozzle ranges. My advice to most oaks is no one actually cares how fast you go through the land. So my advice to most growers, use your pressure gauge as your speedometer. Don't use your speedo as your speedo, use the pressure as your speedo. Because that's actually what's important, is the pressure it's running at. No one cares if you go 25 k's an hour. No one cares if you go 5 k's an hour at the end of the day. But what does matter is that between 5 k's and 20 k's is a very big difference in pressure between those two. So use the pressure gauge as the speedo and that'll solve a lot of your problems. So you make sure, so as we discussed earlier, you get a pressure gauge that you check the drop between your cab and your boom. So make sure that you know that difference because there will be a slight difference. And then basically whatever speed it gets you to operate at the minimum operating pressure of the nozzle, that's the slowest you can go. And the fastest you can go is the high side of whatever operating pressure you want to run it.
Exactly. Vanaf net wij zijn Pieter die pit wat vliegt is zo niet toch. Was dat voor die grond trekken so Jack net very fast so net die boom het vinnig ry lyk dit waar.
Yep.
Ons het gepraat van die mis. Why is it that an aeroplane's wing is possible? How does it work that it is possible to reach the ground?
Yeah, so there are two things with the aeroplane. So first of all, because you've got such a low water volume, you're operating at a very fine droplet. But there are two ways to compensate for drift. You either increase the droplet size, which I'm not going to go over again. I think you guys are tired of that one. The other way to do it is you add more force. What I mean by that, either in a orchard spraying situation, you put a fan behind it, or in an aeroplane situation, you put a wing over it that's basically pushing. There's a down force from the wing pushing the product down, basically. So that's why you can still, that's what helping from the drift point of view with
So I need to put the wing on my sprayer, then I can go at 20.
So you laugh, but you actually, technically speaking, if you did do some sort of, get some engineer guy to design it, and it would help, because you basically, again, you adding. So that's where some guys have those air socks. That's the whole concept with the air sock. It's the same principle. You're basically adding wind. Just be careful of those sprayers though as well, because they are great sprayers if you know how to use them. But they are a lot more technical, because you actually got to calculate the amount of air that comes out of that thing. The same way as with tree crops. You have to actually work out the volume of air, because obviously if you're spraying a pre-emergence and you're pushing the air out big time, you're going to actually land up blowing that stuff all over the place. And the same like if you're spraying a soybean or potato crop. If you don't have your air correctly set, you can actually push the product right through the ground, won't settle. So yeah, but it's the same concept in essence, as long as you get that. So if you get your wing correct and pushing exactly the right amount, it will improve. But yeah, I'm definitely not going to help you with that one. That's for sure.
And nozzle where?
My advice, it depends. First of all, if you've got only one nozzle, if you only want one nozzle, then you need to sort of consider replacing that every year. And the replacement,
1,000.
yeah, because it depends on the amount of hectares. If you've got 1,000 hectares and you only got one nozzle on your machine, I hope you're testing those nozzles regularly, because these things are made out of plastic and you're putting a lot of chemistry through there that's aggressive on these tips. What I suggest to guys is replace every year, is what I would personally do if I was a grower. I know it's expensive, before anyone shouts at me, but this is my reasoning. At the end of the season, set your machine to 3 bar and test your nozzles. 3 bar is what they test the nozzles at the factory. So as long as it meets the flow rate, whatever's in the booklet, at 3 bar, those goes as your spares, and the ones that are out, you throw them away. And then if a nozzle breaks in the season, instead of going back to the corporation and buying another one, you just pull from last year's ones that you've tested that are working. If they're all working, then no need to replace. But then obviously the older those nozzles get, the more time you have to test. Who has time to test nozzles every
Does
week?
the hardness of your water have an influence on the wear rate of your nozzles?
Yeah. Technically, the amount of stuff you're mixing in the tank, the hardness of your water, the quality of your water, is it dirty, all of those sort of stuff. Have you taken all of the filters out? Taking the filters out, that's going to increase the wear rate. I think the easy way to say, for me, I always say nozzles are probably the best place to save money, because at the end of the day, if that thing is worn out only by 10%, basically take whatever your total chemical bill is and times 10%, and that's what you're wasting, just because you don't want to spend money on a nozzle. So again, obviously if you're a smaller grower, that number is going to be very small, but you're a bigger grower, that budget's now much bigger.
And then I clean it with a toothpick.
Ideally, what works the best is all of your old toothbrushes. Don't throw those things away, they are gold. Toothbrush is the best thing to clean a nozzle with. Don't ever stick obviously wire in there, and ideally a compressor is also not really ideal to, it's not a good idea to use a compressor to clean out a nozzle. Old toothbrush, best thing ever. So just make sure your old toothbrushes live inside the spray with the sprayer. Everyone happy? Okay. Do you
What are those cable ties?
Oh yes, yeah, sorry, the cable ties, there's a lot of them, but basically the cable ties, the purpose of this is it's just a nice practical way of making sure that your boom's at 50 centimeters. So you obviously just put that on the boom, you measure 50 centimeters and you cut it, and then you don't have to climb out the cab. If you've got an older sprayer that doesn't have sensors, you can just look out the back of the window and there's your height. and then you'll know. Yeah, so you just put it in, make sure that it's in view from the cab, and you know it's at 50 centimeters or not. Like I said, this boom height is probably one of the biggest factors for drift, and it's the most easy to control. Actually, you just drop it by, make sure it's 50 centimeters. Cool. Thanks, guys.
Right, so nou hopelik weet jy hoe om die regte nozzle te kies vir jou spuit. As jy met Syngenta in kontak wil kom, klik die linkie bo of hieronder en dan kan jy met hulle by hulle hoor wat hulle vir jou aanbeveel in terme van jou produk en hoe jy die goed moet spuit. Dis hier van Farmspace af, tot volgende keer. Groete.